So now I'm going to get into, there are actually two topics that we need to cover this week, okay? One is the topic of UML diagrams, all right? And I'll probably cover that one in the next class because today I want to talk about inheritance, okay? Inheritance is one of the major principles of object-oriented programming, okay? Inheritance, all right? Has anybody in here heard of inheritance before or have any idea what it is who'd like to pipe in? Because I'm curious if you guys have heard of this before. Okay, so you say yes in Java. Okay, so what is it in Java? Can you explain? To give attributes to other classes? No. Okay, you can't remember. All right. So the deal with inheritance is that when we create these objects, you notice we've created lots of different types of objects, okay? Sometimes it is useful to have objects that do a specific thing, and then it's useful to have another object that utilizes a lot of the same attributes and behaviors as the original object, okay? And so the word inheritance comes from the idea that one object can inherit characteristics from another object. So think about like when you were born, okay? Like if your parents both had dark hair, you probably inherited dark hair from your parents, okay? Or the same color eyes or facial structure or whatever, okay? So with objects, it's the same kind of a thing, right? I can have a very, very generic object. Let's say that I have something like a vehicle, okay? Well, a vehicle, might have a type of fuel, or it might have a name, or it might have a color or something like that, that are very generic across lots of vehicles. But it might be that in my application, I want to have something more specific than that, okay? So I might want to have a car, for example, which is a specific type of vehicle, okay? Or I might want to have a boat, which is another type of vehicle, okay? But the point is that whatever characteristics are in that parent object, so that's more terminology, there's a parent-child relationship, right? So the vehicle would be the parent object, okay? And the car would be the child object that would inherit all of the properties of the vehicle, okay? So instead of me just talking about this, I'm going to actually show you some examples in code here, okay? So let me get rid of all this stuff here. All right, so I need to have another topic of something to do today. So what is a topic somebody would like me to cover? Preferably one that we haven't already done before.
Movies.
Movies. Okay, great. Okay, so let's say for a movie, okay, let's say that we're writing an application that is going to keep track of well, let's just see where okay. So all movies have a title. Okay, so let's go ahead and we'll create a constructor. Okay, movies have a title. They probably have, most of them have like a lead actor. So we'll say we'll have like lead actor and like a year that they were made. Okay. And of course, movies have other things too. Okay. A producer, a director, whatever. Okay. But let's just start off with a few things. Okay. So we'll do self.title equals title. Okay. Self.lead actor equals lead actor. And self.year equals year. Okay. So again, nothing that we haven't already done before. Okay. And let's go ahead and make a string method. Okay. And we will return, we'll do self.title plus starring plus self.lead actor. And actually, maybe what we'll do is we'll put the year in parentheses right after the name. So we'll go like this, plus string self.year plus Okay, I think that's a reasonable string. Okay, so let's go ahead and create a couple of examples of movies. We'll do M1 equals movie, and we will do Silence of the Lambs. And that had Jodie Foster, I think, was in that one. And I don't know what year it came out. We'll say 1995. Okay, and then we'll do another movie. We'll do The Godfather. Sure, Marlon Brando and Al Pacino were in that, and that was like 1970 or something. I don't exactly know when that came out. 74, sure. Okay, so now we got a couple of movie objects. Okay, now it's possible that as we're writing our application, we say, you know what? We actually would like to keep track of different types of movies. Okay, like maybe we want to keep track of dramas or comedies or action movies, okay? And maybe those movies are just different enough that it wouldn't make sense to just add all of the different attributes of different types of movies here into the movie classes. So for example, if I wanted to keep track of action movies, okay, I might have a body count attribute, okay? So like I'm looking for action movies where a lot of people get killed, okay? And so it wouldn't necessarily make sense for me to put in a body count here in my movie class because not all movies are going to have like a huge body count, okay? That's something that's really only reserved for, you know, action movies or war movies or things like that, okay? And so if I had another type of movie, let's say that I had a animated movie, okay, I might want to have a bunch of attributes about who like the animator was, okay? And again, that would only make sense for an animated movie, okay? So what we can do is we can create what is called a subclass or a child class of a movie, and the child class will inherit everything that's in the base class or the parent class, which is this movie, okay? And so here's how we do it, okay? I'm going to create a subclass called animated movie, okay? And all you do is you put in the name of the parent class in parentheses like this, okay? And so what this is saying that animated movie is a new class that I'm creating, but it's a subclass of movie, okay? And what that means is that this subclass, animated movie, inherits everything that's defined here in movie. So it inherits this init method, it inherits this self.title, it inherits this string method and everything, okay? So I'm going to prove it to you, okay? I'm just going to put pass. So in other words, this class right now doesn't do anything, okay? But watch this. I can do A1 equals animated movie, okay? And because it inherits this constructor, I can put in the same, you know, I can do Pokemon. I have no idea who the star of Pokemon was, so I'm just going to put Ash Ketchum and 2015 or whatever. I don't know. Okay. And then maybe we'll do Transformers. I think that had Judd Nelson in it, and that was back in like 1992 or something. I don't exactly know. Okay. So now let's go ahead and actually watch this code. Oh, I guess this code doesn't do anything unless I print things. So let me go ahead and print some stuff out. So let's do print M1. Let's print this, and let's print this one. Each. Okay, and let's print this one. Okay, so now let's see if I've coded this correctly. Okay, so we got Python 3, and I called it lecture 9. Okay, so you see that for movie 1, let me separate this into 2 different windows so we can see this a little bit better. Okay, so we see that for okay? Movie 1, so this is, now keep in mind, M1, this is a movie object, okay? It printed out this the way that we thought that it would. Again, same thing for M2, it's also a movie, but A1 is a completely different class. It's animated movie, okay? Yet, you'll notice that it did exactly the same thing as this other one's, okay? And why did it do that? Because the principle of inheritance, okay? Animated movie has inherited everything that is inside of this movie, okay? Now, you might be thinking to yourself, well, that's kind of stupid, okay? This doesn't really actually do anything. So let's make it actually do something different, okay? So in addition to inheriting everything in a movie, okay, we have the opportunity to add new things, okay? And we also have the opportunity to redefine things that were defined here in movie, okay? So let's go ahead and do that. All right, so with an animated movie, the first thing that I'm gonna do is I'm gonna say, you know what? This constructor is all fine and well, but I wanna have my own constructor, okay? Now, an animated movie still has a title and a lead actor and a year and all that kind of stuff, but maybe we also want to keep track of who the animator was, okay? And so in this case, we can do self.title equals title. In fact, I can just copy all of this here. Is somebody trying to say something? Because I thought I heard something, but I couldn't hear what was being said. Still can't hear. I can hear like just a very faint muttering. I don't know. Can anybody else hear? No. Oh, someone just unmuted. Background noise. Okay, that's cool. Thanks. All right. All right. So you'll notice that my constructor so far looks very similar to movie because I still want to have a title, lead actor, and a year, but I also have this animator. Okay. Okay. So maybe I want to keep track of who the animator is. Okay. And so now what will happen is if I try to save this, okay, what do you think will happen when I run this? Okay. Why do you say an error?
You didn't pass one of the arguments, the animator.
Absolutely. Yeah. Okay. Animated movie is now expecting 4 arguments and I've only passed in 3. Okay. So if we go ahead and save this and then come over here and try and run this again, sure enough, we get this error and it says, hey, you're missing 1 required argument animator. Okay. Somebody says, can't we directly start from animator in constructor? I'm not sure I understand the question. What do you mean, can't we directly start from animator? I mean, I could move animator. Why retype title? Oh, okay. So your question is, okay, so this is a good question. All right. So the question is, why do I have to add all of this stuff in here? Okay. Why can't I just do this? Okay. All right. Well, let's see what happens if I try to do that. Okay. If I just do this, okay, now I'm trying to pass in animated movie, okay. If I run this, now it's giving me an error that says init takes 2 positional arguments, but 4 were given, okay. By creating this constructor, okay, I have done something called overriding, okay. I have overridden this function, okay. That's an object-oriented term, okay. I used to have this method init, but I redefined it here in my animated movie. And so now this constructor replaces this one. So this code, I can't use this code anymore right here. Okay. And so in order to get the title, I have to actually put it all back in there. Okay. Otherwise, I can only use what's here, which is this constructor is accepting 1 argument. Okay. So now when I call animated movie, based on this code, I can only pass in 1 argument. Now, in a second, in a little while, today, I'm going to show you how a trick you can do to actually still use this constructor so that I don't have to repeat all the code. But for right now, okay, we're going to have to repeat all the code. Okay, so I'm going to undo all of this stuff that I did. Okay, so now we're back to right here. Okay, so now in order to fix this problem, all I need to do is put in the name of an animator. Okay, I don't know who any famous animators are, so I'm just going to make up Bob Smith. And maybe for this one, it would be Rick Baker. Okay, so there are animated movies. And now you will see that if I run this code, okay, you'll see that now everything works again. Now you'll notice that these animated movies, they don't display anything about the animator because, again, I have not yet defined a string method for this subclass, animated movie, okay? So in other words, it's just using the string class that exists up here that I inherited, okay? So I inherited this string method, and it's just using title, year, and lead actor. It's not using anything else. So because that's all I've got, that's all it's going to print, okay? So it only gets overridden if the method exists. If not, it uses the parent. Yes, absolutely, okay? So in other words, anything that I put up here in movie, automatically you can just assume gets inherited down here in animated movie. The only way that I can change that is if I redefine something that was defined up in the parent class. Okay, parent class, base class, super class, those terms are all used interchangeably. Okay, can you pass more than just one class? So can you inherit from multiple classes? The answer is yes. Okay. And we'll get into that. There's actually a lecture posted on the thing. Dr. Hashmi did a lecture on multiple inheritance. Python is a language that does support multiple inheritance, meaning that a class can be a subclass of two different parents, okay? Java does not let you do that, okay? And a lot of languages don't. C++ does, okay? Now, there are a lot of interesting ramifications and difficulties with multiple inheritance. Namely, suppose that you have two parent classes that have the same attribute name, okay? Which one would the child class inherit? So there are some complications that you have to be aware of when you're using multiple inheritance. But the answer to the short answer to your question is yes, you can have more than just one class. In this class here, IT 209, we're going to focus pretty much exclusively on single inheritance. So just one inheriting from one class and not multiple ones. Okay. All right. So let's see. So yes. So again, because I have not defined a string method here in my subclass animated movie, that means that it's going to go ahead and just use this string method from the parent or superclass. Okay. Now, one of the things that I talked about earlier is it's kind of stupid that, like, for my constructor, I have to repeat all of this same code that I did right here. Okay. So there is a thing that you can do inside the child class or the subclass where you can actually call explicitly methods and features of the parent class or the superclass, okay? And so what that looks like is, I'm gonna actually remove this, this, and this, okay? You can do this. So I can do super with parentheses. Notice that it's highlighted, so it's a reserved word, okay? But you have to use the parentheses, okay? And basically this is saying, all right, I want to get a reference to the super class or the parent class or the class that I inherited my stuff from, and then call methods from here, okay? So I could do dot underscore underscore init underscore underscore, and then I could pass in title, lead actor, and year, okay? All right, so you see what I did? So basically what this is saying is, yes, it's true that I have redefined the constructor, but I still want to use, I've got a lot of good functionality in here that I don't want to have to retype twice because that's lame. So I'm going to instead make a call directly to the superclass reference, okay? And I'm going to call the superclass's constructor, okay? Now, you can do this for any method. So let's suppose that in my movie class, let's suppose that I had another method called show revenue, okay? And it doesn't really matter what this does, okay? But let's just say, for now, we'll just make it say print revenue for this movie is $1 billion, okay? We're not gonna make this method actually do anything interesting for right now, because what I wanna show is that I can actually call this method, again, anywhere I want inside this subclass. Maybe I wanna do it here in the constructor. So I could do, again, super dot show revenue like that, okay? So let's go ahead and see this, okay? So what we expect to happen is our first two movies, Silence of the Lambs and The Godfather, should just print and display as normal. But when we instantiate our Pokemon and our Transformers in our constructor, we have this call to show revenue. So in both cases, we should get out a message saying the revenue for this movie is $1 billion. Okay, so let's see if that works. We go here and we run it. Okay, you will see that sure enough, it printed out the first two movies the way that we thought that it would. And then when I went to instantiate my animated movie, it printed out this line, because this is in my, because this line, the revenue for this movie is $1 billion, is in my constructor. Okay, and then I printed out the actual movie, and then same thing, it did it again. Okay, so the point is that I can call any of the methods here inside my super class using this super method. Okay, now in this case, I don't actually need to call super.showRevenue, because remember, because animated movie is a subclass, I actually already automatically inherited this, okay? So the only time you would need to use super is if you have two methods that have the same name. So for example, if down here I said, you know what, I'm gonna redefine show revenue, okay? And in here, it's gonna be, you know, print the revenue was terrible, okay? Well, now I have a problem, right? Because now I have two different show revenues here in my subclass. I have the show revenue that I define that's specific to an animated movie, but I also have the show revenue that's defined up here in my super class for just a regular movie, okay? And so if I wanted to, let me remove this from the constructor and I'll just put it down here, okay? Is I could make a call again to the super class and do show revenue, okay? And then that would call explicitly this show revenue, okay? Whereas if I just did show revenue, like if I just did over here, if I just said self.show revenue, okay, then that's of course going to refer to this version of show revenue, okay? So in other words, in order to access things in the superclass that have the same name or that have been redefined in the subclass, I can use this super parentheses method, and the parentheses are important, okay? So make sure that you use those. Okay, so does anybody have any questions on anything that we've gone over yet? Will they always be empty? Yes, okay? They'll always be empty, okay? Now, there are actually cases where they won't be empty, but for the purposes of what we're doing here, yes, they'll always be empty, okay? Can you go over super again? Okay, sure. Were you not listening when I when I just went over it? So super, all super does, okay, is, if we think back to this example that I just went over, okay, inside my super class or inside my parent class movie, I have this constructor init that sets up a lot of nice things for me, okay? Down here in my subclass, animated movie, I also have a constructor, okay? And a lot of the things that are done here in this constructor, namely setting the title, the lead actor, and the year, are exactly the same is the code up here in my superclass. So rather than have to retype all of this stuff, I can directly call the superclass's methods by using super. Okay, so that's what I did here. Is I did super parentheses parentheses. So that gave me a reference to the superclass of this particular object. And then I'm going to call the init method of that superclass, which will be this code right here. And that will allow me to set the title, lead actor, and year without, again, having to retype all of these 3 lines. Okay, so I replaced these 3 lines that I would have had to just copy over here into 1 line. Okay, so now the nice thing is that if the base class movie changes and I make my change here, then I shouldn't have to do a whole lot of work down here in my subclass in order to accommodate that change. Okay, did that explain that for you? Okay, good. All right. So let me go ahead and get rid of some of this stuff. Okay, I don't want this show revenue business line around. Okay. All right. So now, in order to complete this exercise, what we need to do is we need to go ahead and override the string method, okay? Because remember, this string method right here, all it does is it returns information about a generic movie, okay? Which in this case, it just has the title, the lead actor of the year. Well, in my animated movie, I have this additional attribute animator that we're not doing anything with. So let's go ahead and we'll do def _ string. And we are going to override. So now we've overridden the string method, okay? Now, again, I could just copy all of this code, okay? And then I could, at the end, say, all right, actually, I'm going to then now add on a animated by plus self.animator, okay? I could do that, all right? But we just learned that rather than recopy this code, there's a different way that I could accomplish this. So what would that be? Does anybody know? Anybody want to guess?
Method? The super?
Yeah, exactly. Okay. So instead, what I'm going to do is I'm going to remove all this. I'm going to make the call to super. Okay. I'm going to call the str method. Okay. Which is this up here. So it's going to give me all of that. All right. And then I am going to add on to that, comma, animated by plus self.animate. Okay, and of course I need to return it. Okay, so if I've done this correctly, then you will see that now for our last two, our first two stay the same, but our last two, we have Pokemon last starring this guy animated by. Okay, so it went ahead. All of this code right here, this beginning part was just, that's what this call to super.str did. It went and called all of this and returned all of that. And then we just added on to the end this animated by. Okay. Does that make sense to everybody? Okay. Now, the other thing that we can do is suppose here in my, okay, somebody says, how come the first method has the attributes, but the second one miss the self? How come the first method has the attributes, but the second one in the super? I'm not sure I understand what you're asking. How come I don't pass self to string? Because remember, you never pass self, okay? Self is just that first argument that you never, that's just implicitly there, right? When I call string, I'm never passing self to string. When I call my constructor, right? When I instantiate my movie, I'm not passing self anywhere in here, okay? So you're never actually, self is just one of those implied things from the beginning where you're never actually passing that. So if you see self here, that means that this function doesn't accept any arguments, okay? So that's why we do it with the blank parentheses, okay? It would be just the same as if I had this, right? If I had def do something, self, okay? And whatever this did, the way that I would call this, right, is down here. Oops, sorry. Over here, all right? I'm not doing m1 dot do something self, you know, or m1 dot do something m1, okay? I'm not doing that. I'm calling it by saying m1 dot do something, okay? That's always the way that we've done it, okay? So that's just the thing about Python, is that that first argument, when we're talking about classes, that first argument is actually a reference to the specific instance. So like in this case, it's a reference to M1, okay? And it's not an actual argument, even though it appears to be, okay? The argument, and that's what allows me to do this dot notation, okay? But in other words, even though do something, it looks like it accepts this parameter. When I call it, I don't actually pass anything in, okay? Did that make sense? Okay, good. All right, so back to what I was saying. So I'm gonna just go ahead with this do something method. So I will say print this method in the movie class does something, okay? Now, if I, in my constructor, want to call the do something method, do I have to redefine it? Okay, do I have to override it down here in order to be able to use it? Okay, one person says yes. Anybody else? Any other thoughts?
No, okay. Can't you just do the super on it?
Okay, can't you just do the super on it? You could, okay? Now, you actually don't even need to do the super on it. And here's why, okay? Remember what I said at the very beginning, okay? Every single thing in this movie class gets inherited by the subclass. So this init method gets inherited, the string method gets inherited, and this do something method gets inherited, okay? So down here, it's as if I copied all of this code and put it down here in animated movie, okay? Well, I have since said, okay, well, I replaced the init method, okay? So now I've got a completely new constructor. I've replaced the string method with a new one that does something different, but I never touched do something, okay? So do something is defined here. It's not overridden or redefined down here, so I can just use it as is, okay? So I could just do like this. I could just do self dot do something, okay? Now, if you look at just this class by itself, animated movie, okay, you're like, wait, where is do something? It's not defined anywhere in here. How can I call a function that's not defined anywhere in my class? And the answer is, well, actually it is defined, because remember, we inherited it. We inherited everything. All of this stuff that's here in movie, we automatically get, okay? The only time, now, I could have also, instead of doing self.do something, okay, I could have done super.do something, okay? That would be fine as well. Now, if you were paying careful attention to what I said earlier, why is it not necessary for me to do the super.do something? Anyone have any ideas? Inherited. It is a unique, yes, it's unique. Okay, that's exactly it. Do something is only defined here inside my super class and nowhere else. okay? So I don't necessarily need to call super, because if I just do self.do something, it's pretty obvious which do something I'm talking about, okay? I need to use super in situations where things have multiple meanings, okay? So in this case, init is defined both in my subclass and in my superclass. So I use this super to communicate that, oh, actually I'm referring to the superclass's init, okay? Not my own. And same thing here in string, okay? So you use the super when you've overridden something and you want to access the thing that you overrode. Okay, so like I said here, I want to access the string method in the superclass, but because I overrode it, I need to refer to it as super so that Python doesn't get confused and say, you're saying string, but I don't know if you're talking about this string or you're talking about the superclass movies string. Okay. All right, so you can do this either way, but the correct way to do it would be to just do self.do something. And to show you that, actually, I'll leave them both in so you can see them working. Now, when we instantiate an animated movie, it should print out this method in the movie class does something twice, okay? And sure enough, it does. So we see this method in the movie class does something, this method in the movie class does something, then we print out that movie, and then it prints it all out again, okay? But again, the correct way to do it is like this, okay? Because again, do something, there's no ambiguity as to what do something is. Do something is definitely this inherited method that came right here, okay? Now, if you go through the lecture material, okay, and if you study object-oriented programming at all, people love to use bank accounts, okay? It's always bank accounts, okay? Because what they'll do is they'll create a kind of a generic method for calculating some sort of like calculating a loan or calculating interest or calculating something. And then they'll override the way that you calculate it in a subclass. Like they might say that a savings account has a different way of calculating something. The interest rate is different or something like that. And so they'll have you override the calculate method. Okay. And again, if you go through the examples that Professor Schumann created that's in our weekly lecture material, that's what you'll see, okay, is that there's like some account information kind of stuff. Okay, so does anybody have any questions about what I've talked about so far? Because what I want to do now is I want to quickly go over the lab and the homework so that we kind of understand what is expected for those items. And then we should basically be out of time. So before I do that, does anybody have any questions? Anything you want me to re-go over that didn't make a whole lot of sense? Okay. I'm going to say that's a no. So let me pull up the, okay, hold on. I need to stop the share. Let me pull up the assignment if I can find it. And I'm going to go over the lab and the assignment. All right, so let's see. Lab 5. And oops. Assignment 5. All right, so let's see. Okay, let me reshare my screen. Okay, so there's assignment 5. Let's all right, so let's talk about the lab first, okay? So in assignment 2, remember assignment 2 was the assignment where we created this character where the character could move around to like a 2-dimensional square. And so we created a move up, move down, move left, move right kind of class, okay? So basically what we're going to do is we're going to say, you know, a character is pretty generic, okay? You know, the character could be a bad guy, it could be a good guy, it could be anything. So we're going to create a subclass. Okay. So we're going to create a new class called enemy, which is a subclass of character. So you remember we just went over how you create a subclass. Okay. And we're going to actually define a brand new method for this subclass. Okay. Called teleport, which will randomly relocate the enemy to a new position. Okay. And then I give you a little, you can use the random.randint function to randomly move the guy to a new spot. Okay. Then we're going to create a second subclass hero called hero, which is also a subclass of character. Okay. So I can create any number of subclasses that I want of the same base class or parent class or super class. Okay. And so we're going to actually create a second class called hero. And then in this example, what we're going to do is we're going to override the move up, move down, move left, and move right methods, so that instead of just moving one square, it's going this hero is going to be able to move 2 squares. Okay, so that's kind of the wrinkle for here. Okay, so this is not super difficult, not a lot of code to get these things done. Okay, but the idea is for you to get familiar with creating subclasses. Now, keep in mind, subclasses should always have an is a relationship, okay? So in other words, an enemy is a character. A hero is a character, okay? And it usually goes from very, very broad to more specific, okay? So a character is kind of broad, that could be anybody, and then an enemy is a very specific type of character, okay? So that's always the test that you want to think about when you're deciding whether or not you want to create a class, subclass, or parent-child, or superclass, subclass kind of relationship. Is it needs to pass the is it a more specific version of the superclass, okay? So for example, if I had a class called car, okay, would it make sense to have a subclass called motorcycle? Anybody know? If I have a class called car, would it make sense to have a subclass of car called motorcycle? Okay. A few people in the chat say no, and you're right. No, it wouldn't make sense because a motorcycle is not a car. Okay. Likewise, if I had a subclass called food, if I had a superclass or a parent class called food, would it make sense to have a subclass called pineapple? Okay. A couple of yeses in the chat. Sure, absolutely, because a pineapple is a type of food. Okay. What if I had a class called instrument? Would it make sense to have a subclass called conductor? Okay. Somebody says yes. Okay. All right. So my superclass is instrument and my subclass is conductor. Okay. Does that pass the is a test?
No, it doesn't.
Is a conductor a type of instrument? No. Okay. A conductor might play an instrument or direct an instrument, but a conductor is not an instrument. So no, conductor would not be a good example of a subclass of an instrument. Okay. A French horn or a guitar or a piano or a drum set, or even a singing voice, okay, all of those things would be excellent examples of instruments. Okay, so that's the thing. This is something that's very, very difficult for people who are kind of new to programming and new to object-oriented programming to realize, is that the is a relationship is it's very, very important for deciding whether something is going to be a subclass or not. Okay, so oftentimes what people want to do is they'll say, oh, okay, well, I've got a character class and I've got a weapon class, so I'm going to make weapon a subclass of character, or character a subclass of weapon. No, just because a character uses a weapon or holds a weapon or shoots a weapon or throws it or something, okay, a character is not a weapon, and a weapon is not a character. Okay, they're two completely different things. So that would not make sense to be a superclass subclass relationship. So somebody asked in the chat, are we assuming that the character class is there, or do we have to rewrite it? Also, for the random.random, is A and B static numbers? Okay, well, A and B is going to be the size of your world, right? So if your world is 10 by 10, then it's going to be 0, 10. You're going to need to do a little bit of reading on randint. Maybe I'll go over it next class if there's time. Okay, but basically randint just returns a number between A and B. So if I do randint 0, 10, it'll return a number between 0 and 10. If I do randint, 6, 8, then it'll return either 6 or 7. Okay, that's how randint works. Okay, but yeah, the numbers that you'll use would just be the size of the board to make sure that he teleports somewhere on the board. Okay, we did randint in IT 109. Good, then you should already know how to do randint. That's fantastic. What do you mean by is new location valid? Well, if your board is 10 by 10, you don't want to teleport to space 50, 62. Okay, it needs to be within that 10 by 10 board, or 5 by 5, however big the board is. Okay. All right. Are we assuming that the character class is there, or do we have to rewrite it? So you should just reuse your character class from assignment 2. Okay, that's what you should do. Okay. All right, and so then the last thing, which we'll talk about next class, is we're going to create a UML diagram. A UML diagram is nothing more than like a picture, like a flow chart kind of thing that just depicts the relationships among classes. Okay, so if you have like a multi-class situation where one class has an attribute that's another class, there's a way to depict that on the diagram. If you have super classes and subclasses, there's a way to depict that, so to just kind of visually see how all of the classes fit together. Okay, and we'll be going over UML diagrams in the next class. Okay, but anyway, that's what we're going to be doing in lab 5. So you're going to be creating a couple of subclasses. Okay, you can use your character class from assignment 2, and you'll get some practice sort of dealing with subclasses. Okay, and if we quickly, let's see, we're almost out of time, but if I quickly flip over to the assignment, you'll see that basically this is actually stolen from a Java course that I used to teach, the IT 206 class, where it looks scary, but it's actually not. Okay, this is less than 100 lines of code total for the entire assignment. Okay, and basically what you're going to have to do, I'll go over this in more detail next time, but it's essentially the same thing. Okay, I'm going to skip all of this narrative, okay, and move down to the bottom, and you'll see in number 1 that we're going to have a customer class, a VM class. Okay, so we're doing a cloud computing thing. We're keeping track of customers who run virtual machines. Okay, and so let me ask this question based on what I just talked about. So customers have VMs. Okay, one customer can have one VM. Okay, should customer be a subclass or a superclass of VM, do you think? Okay, you guys are saying no. Why not?
Because a VM is like a web server or a file server or whatever server you're doing. Where a customer is like, he's not a computer, he's a human being.
Yeah, perfect. Exactly. Okay, that's exactly right. So a customer would not be a subclass of a VM, and a VM would not be a subclass of a customer. Okay, a VM would be an attribute of the customer class, probably. Okay, because in this scenario, if we read through it, the customer has a VM, so the VM is going to be an attribute. Okay, just like we had multi-class. We had objects of objects in our last assignment and on the quiz. But yeah, okay. Now, what you said after that is correct also. Web server is a type of VM, file server is a type of VM, and Bitcoin miner is a type of VM. So those absolutely would be subclasses of VM, okay? So basically what you see is we have a situation where we have a customer class where one of the attributes is going to be a VM, okay? And then the VM could be either it could be just a basic VM with nothing, or it could be a more specific type of VM, which would be these subclasses, web server, file server, and Bitcoin miner, okay? So that's basically all that it is, okay? It looks scary, but it's actually not as scary as it sounds, okay? And then you're going to create some methods and you're going to override some methods and things like that, okay? So, oh, did I remove? Okay, yeah. And then you have to write some test code and then you have to create a UML diagram, okay? So it's work, you know, but it's definitely more doable. So this is what I would encourage you to do. We're over time. I would encourage you to read through this assignment, okay, and come to class on Thursday with any questions that you have. Now, is it enough to read through the assignment? Absolutely not. Start trying to do it, okay? I will say this, if I've said it once, I'm going to say it 1,000 more times. You need to be practicing your Python, okay? It was very, very evident on class that or on the quiz, I'm sorry, that some people have barely written any Python. They probably have fired up their Python interpreter a total of 4 times this entire semester, which was the day that the assignment was due, and they typed whatever they could. Because what I saw on the quizzes, it's very obvious that people have not been doing that, okay? If you want to learn these things, you have to actually write the code, okay? Going back and rewatching this lecture without actually typing anything is not going to do you any good, okay? Same reason why you wouldn't learn to play basketball by watching YouTube videos. You have to actually do it in order to learn it, okay? So start trying to set up these classes and subclasses, and I guarantee you're going to run into questions, okay? When you run into questions, then Thursday is the time to ask those so I can go over them and talk to you about them, okay? Somebody says, is there any feedback? Yeah, so for all of the questions, I did put in information as to why I took off the points that I did. Are you not able to see that? I don't know where to check. I don't know where to check either. All I know is that when I went and graded them for each question, I provided feedback. If I took points off, if you got full credit, I didn't provide any feedback. You have to go through the lockdown browser to see the feedback. Really? That's kind of stupid. I don't see mine as graded yet. I'm pretty sure they're all graded. I'll go back and look and see, but yes, you should be. Has anybody who's on the chat been able to see any of the feedback that I provided to your quiz, or did you guys not even realize they were graded?
I tried to check it, but it said I needed to be on lockdown browser, so I haven't checked it yet.
Okay, so somebody go on to lockdown browser at some point, see it, and then if you have any issues, in the next day or so, where you do that, you go to the lockdown browser and you can't see any of my feedback, then send me an email and let me know, and I'll see if I can fix that. Okay, but yeah, there's definitely some feedback. Now, it's not super great feedback, but it's enough where if you have a question, you can say, hey, you took off points and this was the feedback, and then I can explain to you why I did what I did. Okay. All right. Well, it's past time. I hate it when teachers go over, and I just did it. So I apologize for keeping you guys 5 minutes extra, but we will pick this up on Thursday. We'll talk more about assignment 5, and we will go over UML diagrams. Okay. All right, I'm here for the next 10 minutes or so to answer any questions. If you don't have any questions, you can go ahead and leave. Otherwise, whatever. Yeah, sure. I don't see any more questions coming into the chat. And nobody's saying anything, so I think we'll call it good. All right, good night, everybody. I'll see you guys Thursday.